Okay, good morning. Welcome back. Happy Friday. So we'll start with our quick look. Alex and Irene, you with us? Okay, our quick look at the calendar. Today is Friday, February 6th. We are talking about the topics dimensional analysis as well as ratio and proportion. This is a supplemental section, so you won't find it in your textbook. All the materials that I have to give you are in the notes, along with practice problems in that other packet, all right? Okay, so just a preview of coming attractions. Monday we have new stuff, something called slope, which I think probably many of you have seen before, but it's okay if you haven't. On Wednesday we'll talk about equations of lines, and then on Friday, 1 week from today, is our very first quest. It's called the quest because it's not as small as a quiz, but maybe not as big as a test, something in between. It is going to be a full period assessment. It is going to cover lessons 1 through 5. So all the topics from the start of the semester through Monday's discussion of slope. Okay? Any questions on the calendar? Okay. Then one quick announcement before we jump in on page 23. So I've written on the board here that on my math lab, homework number 3, problem 5, which is about a bar graph and student grades, should not have been assigned here. And I apologize, I put it in the wrong section. And so what I wanted to do was just delete it. But the problem is that some of you have already started homework number 3, which is super. I'm glad you have started homework number 3. But by virtue of somebody having already started that homework, I cannot delete a problem from that homework anymore. So my next best thought was to just tell you what the answer is. So if you could write this down, well, I'll get credit for this problem that never should have been assigned in the first place. So it is homework number 3, problem 5. Put it someplace that you will see it when you are doing your homework. And up here is written the answer, which you'll type in is 0.775x plus 20. Again, make sure you put this someplace that you will see it when you are going to do your homework for number 3. Homework 3, problem 5. You're going to type in 0.775x plus 20. And I wrote this thing about the bar graph and the student grades just so you would know what to look for, so you would know you were looking at the right question. So look for something with a bar graph and student grades. Sorry. Any questions on this? Again, I apologize. That's my mistake. It will not be the last one I make this semester. All right, so let's jump in with the daily summary on the top of 23. Savannah? Thank you. Tyler, number 1. Okay, so write down some expression that represents how we would figure out how much money we'd have to pay. $3.57 a gallon, 12 gallons, and then $15.35 on other stuff. I'll have something written down. How would we figure out, good morning, how would we figure out what this costs? Tyler? Tyler says that. Agree? Makes sense? Okay, so let's go down to number 2 here, and let's go to Cody.
Hopefully you wrote something similar. Numbers above don't have any
Okay, and so units is a word we talked about last time, and so let's just refresh our memory. So some units are feet and seconds and pounds and all the things that we all recognize, like what the standard, what it means, like what 1 pound means, what 1 second means, and that's how we measure all the other things, by comparing it to our standard 1 second, 1 pound. So what are the units of this 5819? Those are dollars, right? And everybody here knows what $1 means, and so therefore we know what $58.19 means. So let's go to number 3 here. It says, let's examine what happens to the units when we perform the calculations, but we're actually going to write in the units for all of the numbers in this expression that we came up with in the beginning. So remember, it was 357 times 12 plus 1535. 357 times 12 plus 1535. So let's get some units up here. What was that 12 measuring? 12 what? 12 gallons. Okay, somebody else? How about that 1535? That's dollars. Okay, I'll put the dollars on the right, which looks funny, but. And how about this 5819? Also dollars. Okay, somebody we haven't heard from, the hard one, is that 3.57. It's 357 what per gallon? Dollars per gallon, right? That's the complicated one. It's $357 per gallon. Okay, and so the units on the left have to equal the units on the right for this equation to make any sense. And so something nice happens on the left-hand side. If I just look at dollars per gallon times gallons, I'll just write it over here on the side. Dollars per gallon times gallons. You guys see what nice thing happens there? You can cancel, right? Because the gallons on the second part, I'll put it over 1 so it really looks like a fraction. And we know that when we're multiplying fractions, you can cancel anything on top with the same thing on the bottom. And so the gallons just completely cancel. And so the units for this entire thing right here turn out to be just dollars because those gallons cancel. And so then we are adding, underlined here in blue, dollars plus some more dollars. And when you add dollars and dollars, what do you get? You get dollars. And so the equation makes sense. I mean, it made sense without the units, but I want to highlight the units because it's going to help us set things up today. Okay, so let's move on to number 5. Before we do, there are a couple people that came in after I made some announcements. Tyler, can you share with them just this number, this answer here? Thank you. Okay, so moving on to 5, Lucas.
How we change gears and talk about ratio. How we change gears. We'll see that eventually.
Thank you, Alex. 6. Okay, and Irene? Okay, so lots of vocabulary here. We're about to solve this proportion. I'll highlight it in green. It's the same thing written in both places. So 2 techniques for solving a proportion are either cross multiply, which is probably some phrase from your past, or multiply both sides by both denominators, which if you had Sandy last semester is definitely a phrase from your past. We'll see them both. But again, some vocabulary. So first, a ratio is just a fraction. And so x minus 1 over 7 and 3 over 5 are both just ratios, just fractions. And if you have 2 fractions equal to each other, like in our green highlighted things, that is now called a proportion. It's just vocabulary. You're not going to see like any vocabulary on our upcoming quest, not like explicitly saying, hey, define a proportion, but you need to know it so that when you read it in the book or when you hear me talking about it or you read it in the notes, you understand what we're referencing. Ramses. Test is in class, pencil and paper, just normal. Yeah, good question. So it's in the syllabus calendar, and it says here that it's lessons 1 through 5. Yeah. Okay. So our 2 basic techniques, cross multiply or multiply both sides by both denominators. So the details are written out. We're going to go through this kind of quickly because I'd rather have you spend time doing math than reading math with me. But cross multiply is something where you are told, okay, we just get to multiply on the 2 diagonals. And whatever we get, those 2 things are equal to each other. So multiplying 3 times 7, that's right here, turns out to be 21. And then multiplying on this side, it's just 5 times x minus 1. Right? Have we seen cross multiply before? Okay, and then we continue, distribute over here. That gives you the 5x minus 5. Add the 5 to both sides, right? That gives you 26. And then finally divide both sides by 5 to get 26/5. So that's the answer to this proportion. Another way is to multiply both sides by both denominators. So here's the same original starting equation. both denominators. There's a 7 and there's a 5. So we're going to multiply both sides by 7 and 5. Now this seems like a really reasonable thing to do, or at least a legal thing to do, right? As long as you do the same thing to both sides of the equation, you're fine. And so it's not clear why we're multiplying both sides by 5 and 7, but as long as we're consistent and we do it on both sides, it's legal. And if you multiply over here by 5 and 7, you notice that what cancels? The 7's, right? That's why we put the 7 there, was explicitly for the purpose of canceling it. Don't write it as 35. You're burying what's really going on. The 7 is there, so you cancel it. So we just cross off the 7's, and then what we have left is just 5 and an x minus 1, no fraction. And what happens on this side? The 5's cancel, and that's why you put the 5 there. And so all we're left with is this 7 times the 3, which is right down there, right? And so you put the 5 on one side to cancel, and you put the 7 on the other side to cancel, but you got to put everything on both sides. So we have this equation right here. And that equation right there is exactly the same as this equation that came from cross multiplying. Okay, so if it's so much shorter to just cross multiply, then why don't we do it? Well, cross multiply was just this magic technique that you have memorized. And I'm guessing that you didn't understand it was because you were multiplying both sides by both denominators. And so it's just this like magic thing. And I think there's a real danger. I mean, first of all, I don't like just memorizing magic things. I like to understand what's going on. But there's a danger in that a lot of times when they see that proportion and they say, oh, I know I'm supposed to cross multiply, and they'll do this. 5 times x minus 1, right? And then 7 times 3 is the other one. And they'll come up with that. And they'll know they're supposed to multiply the two diagonals, but they'll have no idea that it's supposed to result in a brand new equation. They'll keep it as a fraction and then know where to go from here. This fraction is not part of the problem. It's that the two pieces should be equal, not that we've built a new fraction. The other reason I'm not thrilled with cross multiply is that suppose that I asked you this problem, x minus 1 over 7 times 3 over 5. This is not an equation. This is an expression. How do you multiply two fractions?
You have to find the least common.
So least common denominator comes up when we add fractions or subtract fractions. But multiplication is actually even easier. You just multiply straight across the top and straight across the bottom. Super. So then the answer here is just x minus 1 times 3 divided by 7 times 5. We could clean it up a little bit. But that's the answer to this one. It depends on what you're after. Distributing the 3 is a natural thing to do. Yeah. Okay, so here's the problem, is that if you just memorize cross multiply and don't really understand what's going on or why it works, then you might see this multiplication problem and think, oh, I should cross multiply. 5 times x minus 1, 3 times 7. But that's not how we multiply fractions, right? Fractions go straight across. And so there's a real danger in memorizing this like magical technique for proportions that you might misapply it to a multiplication of fractions problem. Okay, let's move on to the next page. And we will try a word problem, Ramses, number 8. Okay, so here's our definition. The problem is asking how many females there are. Seems like that's the best thing we could use a variable to be. It's how many females are there at GCC. So we'll let x equal the number of female students here at GCC. And I want to point out that there is a quantity word in there, number. If I just said let x equal females, that's not a good variable. X equaling females does not make sense. It just doesn't make sense. What are you talking about with the females? Are you talking how many females? Are you talking how many eyes do the females have? Are you talking how tall the average female is? I mean, there are a lot of things you could measure, right? And so you want to be really clear when you define these variables. So here it is the number of female students. Okay, so here's how we're going to solve this problem. We set up a blank proportion with two fractions being equal. That's done here. A lot of what I'm about to say is written out. You can read it later, so we're just going to do it and kind of ignore all the text. But we start with two fractions being equal. Next thing we're going to do is we're going to put some units on top and on the bottom on the one side. The two relevant pieces of information here, it seems like, are female students and male students, right? It makes no difference what order you put them in. I will arbitrarily choose to put the number of females above and the number of males below. It's totally fine if you have that flipped over. But as soon as I make a choice on the one side, I am bound to make exactly the same choice on the other side. Okay? So you make a choice, and then you got to stick with it. Be consistent. Okay. So now we're going to start filling in those blank lines with numbers or numerical things. So looking up there at the first sentence, it says the ratio of female students to male students is 3 to 2. Those numbers, 3 and 2, go on this first fraction. Everyone agree? Let's pause there. Ramses says 3 on the top and 2 on the bottom. Are we comfortable with reading that, you know, whatever the first word is goes with the first number, and then the second word goes with the second number? What's the key word in between that we'll always see for ratio problems? 2, right? That's telling you the colon. Okay, so the word 2 is always going to be in between these things. So first word is females, has to go with 3. And we chose females on top, so 3 goes on top. Okay, other fraction. Again, we're going to just fill in these 2 blanks of the fraction. Yeah, x is the number of females, right? That's our generic variable for number of females. So we're going to put x on the top. And now finally, that last blank. This is the tough one. There's one other number in this problem we haven't used. What is it? Is the 2000. So it's really tempting. Don't copy this. But it's really tempting to just put 2000 down there. But it's, yeah, that's all the students. And we know that the thing in the bottom is supposed to just represent the number of male students, right? So you can't just put 2000 down there. It's got to be something with x in it. Yeah, Lucas. X, Lucas says 2000 minus x. What do we think? Yeah, because every student here is either male or female, and x of them are female, so all the rest must be male. And the rest is represented by 2000 minus x. If that is a leap, and it's totally okay if getting to 2000 minus x is a leap, what do? The technique from last class was just pick a random number. Suppose x is equal to 300 women. If there are 300 females here at GCC, then how many males are there? Easy, right? 1,700. So how did we get 1,700? What was the actual calculation that we did? I mean, you might have to pause to think about it because you do it without even being aware of what you're doing. But where did 1,700 come from? Right, we did total number of students minus the 300 that we just made up, right? That's how we get 1,700. And then you say, okay, but it wasn't really 300. It was really supposed to be x, right? And that's the 2000 minus x. So the make up a number technique, I think, is a great one if you are trying to set up some algebraic expression but don't know how. Yeah, so if you can just see the 2000 minus x, don't worry about it. But if you just don't know how to get to this algebraic way to represent males, make up a number and oftentimes it'll just fall right out. Okay? All right, so that is the proportion that we are going to solve. 3 over 2 equals x over 2000 minus x. And in fact, solving that proportion, that's the thing that we've written right down here. Solving that is going to be the first thing in the activities today. So I want to do one more example together, and then the first part of the activities, you will finish this problem by solving that proportion. So we're going to move on to this in the US part. So have you read yet, Ron? Yes. Let's go to Will for in the US. Thank you. Okay, so the first part said a baby is born every 3.2 seconds. So writing that as a ratio, 1 baby per 3.2 seconds. Notice that I've got the words in there, baby and seconds. And ultimately, here's the goal. The goal is to figure out how many babies are born Each decade. That's what I'm after. How many babies per decade? Okay, so here's what we're going to do. We're going to multiply this thing here by a certain number. Now, if I multiply this fraction by 17, will it still be equal to what it's equal to now? If you multiply a number by 17, does it change or stay the same? It changes, right? What's the only number you can multiply by where the thing doesn't change? Is 1, right? 1 is that magical number. You take something, multiply by 1, you haven't changed anything. So the only thing we're allowed to do is multiply by 1. But we're going to multiply 1 by 1 in a very special way. So here are your two choices. Would you guys agree that 1 minute is the same as 60 seconds? Don't write that down. But everyone agrees 1 minute is the same as 60 seconds. And so if you agree that this is a fraction where the top thing is equal to the bottom thing, what's the value of any fraction where the top is equal to the bottom? It's 1, right? Like 5 over 5 is 1. So that right there, that fraction is 1, which is great because that's the only thing I can multiply by. Have I built this fraction in the right way so that the seconds will cancel? No, I put seconds on the bottom, but I wanted to cancel it and it was already in the bottom. So really the seconds should have been on the top. So then given that, I say, oh, okay, great. I should have put seconds up there, which I guess means minutes are down here. And then what's the number of seconds that we're going to put? 60 there. And then how many minutes? Is 1 minute. And if we do that, then the seconds cancel. And all of a sudden I went from babies per second to babies per minute, which is still pretty far from babies per decade, but it's heading in the right direction. What's the next natural unit of time, bigger than a minute? Is hours. So we're going to multiply by something with hours in it. You are hoping to cancel those minutes right there. So where do the minutes go? Up top, to cancel the one that's already there, right? You don't want to guess here. You want to let the position of that word guide you to decide whether to multiply by that fraction or the flipped over version of that fraction. And then we put some numbers in. How many minutes? 60 minutes is the same as 1 hour. And just like that, minutes cancel. Okay, so here's the plan. With your neighbors, you are going to finish this problem and ultimately type something into your calculator at the very end, but write out all of these words and cancel all of the words until you get, again, to babies per decade. That's the goal, okay? So keep multiplying out. When you have babies per decade, you're good. Type something in the calculator. And once you finish that, you can move on to the activities, which are not the next page, but the one after.